Water heaters and dryers use different wiring configurations, specifically 10-2 wire with ground for water heaters and 10-3 wire with ground for dryers, due to the different ways they use electricity to generate heat. Firstly, consider the water heater. A water heater is designed to heat water gradually over an extended period. This process requires less instantaneous power. The heating element in a water heater operates almost continuously to maintain the water at a set temperature. Because the heating is slow and sustained, the electrical load is relatively constant and doesn't require the same high power delivery as a dryer. The 10-2 wire with ground configuration is sufficient for this purpose. This setup includes 2 current carrying conductors, one hot and one neutral, plus a ground wire for safety. The hot wire provides the electrical power, the neutral wire completes the circuit, and the ground wire offers a path for fault current in case of an electrical issue, preventing shocks. Secondly, let's examine the dryer. A dryer, on the other hand, needs to generate a significant amount of heat quickly to dry clothes efficiently. This rapid heating requires a higher power draw compared to a water heater. The 10-3 wire with ground configuration is used to supply this high power. This setup includes 2 hot wires, a neutral wire, and a ground wire. The 2 hot wires are connected to a 240-volt circuit, providing twice the voltage compared to a standard 120-volt circuit. This higher voltage allows the dryer to draw more power, enabling it to heat the air inside the drum more quickly. The neutral wire is used for the dryer's 120 volts components such as the timer, lights, and controls, while the ground wire provides the same safety function as in the water heater circuit. To further understand the differences, consider the analogy of a slow cooker versus a stovetop. A water heater is like a slow cooker, which is designed to cook food slowly over a long period at a relatively low temperature. This process requires less power and is more energy efficient for tasks that don't need to be completed quickly. A dryer is like a stovetop, which is used to heat things up quickly at a high temperature. This rapid heating requires more power, but is necessary for tasks that need to be completed in a short amount of time. In summary, the wiring differences between water heaters and dryers are determined by their respective heating needs. Water heaters use 10-2 wire with ground because they heat water slowly and steadily, requiring less power. Dryers use 10-3 wire with ground because they heat air quickly to dry clothes efficiently, requiring more power. The 10-3 configuration provides the necessary voltage and amperage to support the high power demands of a dryer. Understanding these differences is crucial for ensuring safe and effective electrical installations in your home. When dealing with electrical work, it is always best to consult a qualified electrician to ensure that all wiring is done correctly and safely. It is important to remember that electricity can be dangerous, and improper wiring can lead to electrical shocks, fires, and other hazards. Always follow local electrical codes and regulations when working with electrical systems. Electrical codes, such as the National Electrical Code or NEC, provide specific guidelines for wiring different types of appliances and equipment. These codes are designed to protect people and property from electrical hazards. When installing a water heater or dryer, it is essential to follow the manufacturer's instructions and any applicable electrical codes. This will help ensure that the appliance is wired correctly and operates safely. For example, NEC Section 422.31 covers the wiring requirements for appliances, including water heaters and dryers. This section specifies the type of wiring, overcurrent protection, and grounding requirements for these appliances. Similarly, NEC Section 250 covers the grounding requirements for electrical systems. Grounding is an essential safety measure that helps prevent electrical shocks and other hazards. By properly grounding electrical systems and equipment, you can provide a path for fault current to flow back to the source, tripping a circuit breaker or ground fault circuit interrupter, or GFCI, and energizing the circuit. This can help prevent electrical shocks and other injuries. In addition to following electrical codes and manufacturer's instructions, it is also important to use the correct tools and equipment when working with electricity. This includes using insulated screwdrivers, pliers, and other hand tools, as well as a voltage tester to verify that circuits are de-energized before working on them. It is also important to wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves to protect yourself from electrical hazards. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. An electrician has the training, experience, and tools necessary to perform electrical work safely and correctly. By following these guidelines, you can help ensure that your electrical systems are safe and reliable. Water heaters typically use 120 volts or 240 volts, while dryers typically use 240 volts. The voltage and amperage requirements of an appliance determine the size of the wire needed to supply power to the appliance. The larger the amperage, the larger the wire size required. This is because larger wires can carry more current without overheating. NEC Table 310.15. B16 provides guidance on the allowable ampacities of insulated conductors. This table specifies the maximum amount of current that a conductor can carry safely based on its size, insulation type, and installation conditions. When selecting wire for an electrical installation, it is important to consult this table to ensure that the wire is properly sized for the load it will be carrying. In addition to wire size, it is also important to consider the type of insulation used on the wire. Different types of insulation have different temperature ratings, which affect the amount of current the wire can carry safely. For example, THHN insulation is rated for higher temperatures than TW insulation, so THHN wire can carry more current than TW wire of the same size. When selecting wire for an electrical installation, it is important to choose a wire with the appropriate insulation type for the application. It is also important to consider the installation conditions when selecting wire. For example, wire that is installed in a conduit or raceway will typically have a lower ampacity than wire that is installed in free air. This is because the conduit or raceway restricts the flow of air around the wire, which can cause it to overheat. When selecting wire for an electrical installation, it is important to take into account the installation conditions and vary the ampacity of the wire accordingly. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. These devices are designed to trip or blow when the current in a circuit exceeds a certain level, interrupting the flow of electricity and preventing damage to the wiring and equipment. The size of the overcurrent protection device must be matched to the ampacity of the wire it is protecting. If the overcurrent protection device is too large, it will not trip or blow when the current exceeds the ampacity of the wire, which can lead to overheating and fires. If the overcurrent protection device is too small, it will trip or blow unnecessarily, interrupting the flow of electricity and causing inconvenience. When selecting an overcurrent protection device for an electrical circuit, it is important to consult the NEC and follow the manufacturer's instructions. The NEC provides specific guidelines for sizing overcurrent protection devices based on the ampacity of the wire and the type of load being served. The manufacturer's instructions provide additional information on the proper installation and operation of the overcurrent protection device. Ground fault circuit interrupters, or GFCIs, are used to protect people from electrical shocks. These devices are designed to detect ground faults, which occur where electricity flows through an unintended path to ground. When a GFCI detects a ground fault, it quickly interrupts the flow of electricity, preventing an electrical shock. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electrical shock. GFCIs are also recommended for use with portable electrical tools and equipment. When installing a GFCI, it is important to follow the manufacturer's instructions and test the GFCI regularly to ensure that it is functioning properly. Electrical safety is a critical concern for homeowners and electricians alike. By understanding the principles of electricity, following electrical codes, and using the correct tools and equipment, you can help ensure that your electrical systems are safe and reliable. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. The difference in wiring between a water heater and a dryer primarily stems from the different power requirements for heating. A water heater gradually heats water, requiring a consistent but lower power supply, making a 10-2 wire sufficient. In contrast, a dryer needs to heat clothes quickly, necessitating a high power draw achieved with a 10-3 wire to accommodate a 240-volt circuit, allowing for faster and more efficient heating. This distinction mirrors the difference between using a slow cooker for steady, low-power heating versus a stovetop for rapid, high-power heating.